Let's talk about discontinuity in rational functions. So rational functions are functions that are written as fractions that consist of a function in the numerator and a function in the denominator. So for example, something like this, x divided by x minus 1. Now, I hope the first thing you notice here is that we have this spike in the graph at 1. We call this a vertical asymptote. And you can see here that if I were to try and evaluate this function at 1, I'd have 1 over 0, and I can't divide by 0. That's what causes this asymptote to occur. So that's one type of discontinuity in a rational function, is a vertical asymptote. Now, if I were to do something like this, let's say that I added another thing on the denominator that would make that 0. So now you can see I have x minus 1 and x plus 3 both in the denominator. So now I have two vertical asymptotes. I have one at positive 1, because if I evaluate, 1 minus 1 would be 0. And I have another at negative 3, because negative 3 plus 3 would be 0. So these asymptotes, these discontinuities, happen anytime I'm dividing by 0, any x value that would cause that to happen. Now, an interesting thing can occur here, and I should just say the discontinuities, if you were asked, what are the discontinuities? They are x equals 1 and x equals negative 3. In the numerator, though, if I were to change this to be x minus 1, now you can see that I only have the one vertical asymptote. So again, going back here, I had 2. The minute I make this x minus 1, I only have 1. Let's say instead I was like x plus 3. Well, again, I only have 1, but now it's at positive 1. The discontinuities are anything that would make the denominator 0. But we have two types. Once we are able to simplify this, like that, the x plus 3's divide out, that gives us our vertical asymptote. So the vertical asymptote is at x equals 1. It's this vertical line that it kind of spikes around. The one that factored and divided out, we call a hole. Now, in Desmos, it's really difficult to see that because it just makes a smooth graph, but there is a hole at negative 3 in this graph. So again, both of those are considered discontinuities. When you're asked what could make the function discontinuous, it's anything that would cause the bottom to be equal to 0, any value of x that I would plug in and get 0 in my denominator. But then we can further classify them as either a vertical asymptote, that's based on if we had a common factor, we divided it out, and we're left with just x minus 1. So only 1 would cause us to divide by 0, and therefore the one that divided out, we still consider a discontinuity, but we don't see that asymptote anymore. If this video helped you, please like and subscribe for more math help.